set in when we're starting to flatline. So we have diminishing marginal utility as we enjoy more and more of the good. Now, our indifference curves, are the comparisons. That's on a video. Are the comparisons between two goods where we're looking at the rate at which we're indifferent, or the combinations in which we're indifferent between having another unit of one of the goods from where we are presently. Let me erase my board here. Okay, so I'm going back to my pizza and CDs. Here. So if I'm currently at this level of consumption, what could I say I am? Well, I have a lot of pizza, but I don't have that much for CDs, right? Well, if I have so much pizza and not so much to listen to, wouldn't I be pretty content to give up a fair amount of pizza just to have a little bit more to listen to? Because I have so much pizza. Thinking back to that last model, if I have so much pizza, I'm probably in the area of diminishing marginal utility for pizza. So backing off of that would mean very little to me if I could get just a little bit more to listen to. Or if I had plenty to listen to, but not very much pizza to eat, then I'm in diminishing marginal utility for pizza. And so backing off and not having so much, I'm in diminishing marginal utility for CDs. So backing off of that, not having so many CDs, I'd be pretty comfortable with doing that if I could get just a little bit more pizza. So that means that we have some kind of a trade-off in our utility between these things such that it's going to form a curve in which at any point on the curve, I'd be indifferent to moving along the curve to another point on the curve. And it's going to always be, this is convex toward to the origin. It's always going to be bowed inward like this. I hope I have the right term since this is on video. I'm doing that from memory. So don't hold me to that, but I'll double check that I'm right. You can do the same. It's hard to get the concept of being indifferent between here and here. But it's like being like, oh, okay. The way to get it is to compare it to being here or being here. Because I wouldn't be okay with being here relative to here. Because if I'm here, I have way less of something, at least. If I maintain, I have less of both. I have less. That's as simple as that. I have less of both. So if I'm on an indifference curve like this, and I move down to this, this is an inferior curve or less desirable curve than this one because it's less of both. I can be indifferent between here and here, but I'm not indifferent between here and here. This is better. This is better still. So the moral of that story is the curve farthest from the origin is most desirable to me. It's higher satisfaction from the two goods. But the individual curve along a single curve is a place where I'm cool with being here or here, which means the curves can't cross. They have to run in some kind of a parallel way, the shape being determined by your taste tastes and preferences, but they can't cross, because if they crossed, it wouldn't make sense for us. You can't be indifferent between here and here and here and here, because here this is more of this and this than there. How can you be indifferent between there and there? But if you're indifferent, if it's truly indifference, you're saying that you're indifferent between here and there. But that's also on this curve, where there's no way you would be indifferent between these two. So the curves can't cross. That's one characteristic of them. So that means for us, for each of us in our minds, even though we don't necessarily have the ability to sense this, we have some indifference curves that are mapped out that just go on into infinity, all compressed together. And for us, what this means is the farthest one we can be out on, the more satisfaction we have from the goods. So indifference curves farther from the origin are better than indifference curves closer to the origin. Now, I have one other term in my notes that I noticed, two terms. Well, one I have said, marginal utility. This is actually quite reviewing. The satisfaction that one more unit will bring to the consumer. That's marginal utility. So we looked at diminishing marginal utility before with that utility curve, utility function. But then this leads us to the marginal rate of substitution. The rate that the consumer will trade the two goods without a change in utility. Indifference curves are curved because this rate is different depending on how much of each good the consumer has. So that's a long way to say what I think we just said. Moving along a curve, I can be indifferent between a very high number of something and only a little of the other, and moderation of the two, or a very high number of the other and a little of the first thing. But I'm always going to prefer to have more of both things, or some combination where I would be indifferent to having more of both things than some other combination below that. Let me make sure I address that. The rate, this is marginal rate of substitution, the rate that the consumer will trade the two goods. So if I'm looking at a graph and I'm talking about the rate, what am I talking about? This is something for math people, if you're a math person. If I'm looking at a graph, and I'm referring to rate, what's another term for rate along a graph? Oh, that's right, the slope. So the marginal rate of substitution is another way of saying the slope of an indifference curve. And notice they do not have a constant slope. They have a constantly changing slope because they're curved throughout. So our marginal rate of substitution is the relative utility I can get from one good to the other good along an indifference curve. It's the slope along this line, and it's ever changing as I go along the line. And I think that's a nice breaking point for video number 2. As I was talking, I was thinking, and I think I'm going to do a third video for this consumer choice theory. And I'm going to, now what I'm going to do is put together in the third video, I'll put together the budget constraint from the first video and the indifference curves from this video.